Hello everyone, I'm Roshni and today I'm going to tell my topic is procedure for converting infix expression to postfix expression in data structures. So let's dive into that. Introduction to infix and postfix expressions. Like infix expressions are the most common way of writing expressions using operators between operands. Like postfix expressions, also known as reverse Polish notation, place operators after their operands. Understanding the conversion process from infix to postfix is essential for evaluating expressions in programming and algorithms. Why convert infix to prefix? So infix expression can also lead to ambiguity in operator precedence and parenthesis. Postfix expressions eliminate the need for parenthesis, making it easier for computers to evaluate expressions. Converting to postfix simplifies the expression evaluation process, particularly in stack-based algorithms. So a a so these are a operators and operands are there. So these are operators and a b c are operands. So operators are pushed to the stack and operands are resulted, like they are pushed to the queue, like c. Operators add, like operators push to the stack, so these are pushed to the stack and operands results. B push to the results. So A first we are taken some infix expression C A plus B into open parenthesis C power D minus E. So we are taking A. A is an operand, so we are taking that as a result, and plus is an operator, so we need to push that into the stack, and b is an operand, so we need to push that as an operator, so the result is ab, and star, like multiplication, is an operator, so we need to push that into the stack, so we have pushed this. So and we are following the precedence, so which has higher precedence, so star, like multiplication, has higher precedence than plus, so it becomes first. And now open parenthesis is we need to push that to the stack, and now we got C is an operand, so we are push that into the results, and this power is an operator, so we need to push that into the stack, and we need to see that which has a higher precedence. And here D is an operand, so we need to push A B C D, like from the previous. And now there is a negative, like subtraction, so we need to like minus has a lower precedence than power, so we need to add this push to the stack, so we are pushing this to the stack. And add E to the resultant, and here pop, like power pop. Why? Because we are deleting this from the stack and add to the result, because we are checking the precedence here, minus and power. Here minus has a low precedence than power, so we are deleting this from the stack and we are pushing this to the result. Now we are pushing again negative, like minus, and we are adding e to the result because it's an operator, like operand, and we are popping minus from the stack and adding to the results, because we are processing, like we should do process until we need that from the results, we need that to the results, because there is a closed parenthesis, so that's the reason why we are again popping out from the stacks to the results. So the final expression, postfix expression, is a b c d e e b c d power e star minus star plus. So this is the postfix expression, final postfix expression. So we are converting infix expression to postfix expression. Now, operator precedence and associativity. See, we have talked about the precedence of the operators, right? Operator precedence determines the order in which different operators are evaluated in expressions. The common operators include addition, subtraction, multiplication, and division, each with its precedence level. Associativity defines the order of evaluation for operators for the same precedence, typically left to right or right to left. We can do left to right or right to left. We all know that this is parenthesis, open parenthesis, square, like arithmetic operation, relational operation. These are logical operators, and this is an assignment operator, like assignment equal to. And overview of the conversion, like the conversion from infix to postfix can be achieved by using shunting add algorithm developed by Richard Dijkstra. This algorithm utilizes a stack to hold operator and ensure proper output of the resulting postfix expression. The main steps include reading the infix expression, handling operators and operands, and managing them. Read the infix expression from left to right, token by token. We have already seen the example, and these are the procedure to follow, like step-by-step conversion process. Like operands are directly added to the output, while operators are pushed onto the stack based on the precedence. We need to see the precedence, and then we need to push them into the stack. When encounter parenthesis, special rules apply to ensure correct grouping the output. Yeah, we need to careful about open and close parentheses. Let's consider an example in fix. Your second word. In this expression, we have two operands like a and b, and one operator plus with another operator. Open parenthesis. So we need to start with an empty output and stack. We read A and add it to the output. So we are taking A and we are adding it to the output. And next we encounter a plus addition operator, which is pushed onto the stack, followed by B, which is added out. And then we are again popped out. So once the entire infix expression has been read, we pop any remaining operators from the stack to the output. So for example, is popped out first by followed by minus, resulting in the final postfix expression. Postfix notation allows for straightforward evaluation using a stack-based approach without worrying about operator precedence. It can facilitate easier implementation in programming languages and calculators that support RPN. Understanding postfix expression is vital for optimizing code and improving computational efficiency. So these are again examples. We have already seen an example. So let's move on. In conclusion and key takeaways, like converting infix expression to postfix expression is a valuable skill in computer science and data structures. The shunting algorithm provides a schematic approach to achieve this conversion effectively. Mastery of postfix notation can enhance your ability to write coefficient algorithms and understand expressions evaluations. So these are things we have already seen precedence order. So thank you.